Hello viewers. Now we'll see horizontal curves. So if this is a straight road where there is a vehicle, then there is no problem. If there is a curve, the vehicle is traveling, then what will happen? Centrifugal force acts on the vehicle as the vehicle is turning. Suppose this is the centrifugal force and W is the weight of the vehicle, then resolving, if B is the width of the vehicle and H is the height of the centroid of the vehicle, that is center of gravity of the vehicle. Then resolving this, we get E into H is equal to W into B by 2. So P by W is equal to B by 2H. This P by W, the centrifugal force and weight of the vehicle. This ratio is called centrifugal ratio. So at curves there can be two things that can happen. So there can be overturning of the vehicle. So overturning of the vehicle or skidding of the vehicle may happen. Vehicle may skid or it may overturn also. It is moving like this, it may overturn like this. So overturning, to avoid overturning and to avoid skidding, what to do? So the road is straight, but at the curves what we'll do is, we'll keep this, the outer edge, a little higher than the inner edge. This is called super elevation. And this angle is called rate of super elevation. This is actually sin theta, that is opposite side by hypotenuse, that is width of the road. This height by width of the road. Since theta is very small, we take it as tan theta and we simply write it as small e, which is rate of super elevation. Also, we have coefficient of friction, lateral friction. So lateral friction along the road. So F, that is coefficient of lateral friction. So centrifugal ratio is counterattacked by rate of super elevation and lateral friction. So P by W, that is E plus F. So we don't need all the derivation. So what we simply write is E plus F is equal to V square by GR. We don't need the derivation. And coming back to this point, to avoid overturning of the vehicle, this ratio should be, the centrifugal ratio should be less than B by 2H, and to avoid skidding, this centrifugal ratio should be less than coefficient of lateral friction. So generally coefficient of lateral friction is taken as 0.15. This is centrifugal ratio. Now, how to adapt super elevation? Now we'll see that. How to adapt super elevation. So this E, we will see rate of super elevation So we have this equation. So V is the design speed of the road, acceleration due to gravity, radius of horizontal curve, rate of superellation and friction. Now what will happen is, first point, we will adopt that there is no friction and E is equal to so 3/4 of the centrifugal ratio is enough, that is 0.75 into design speed. 3/4 of the design speed will counteract the centrifugal ratio and adopting there is no friction. So E is equal to this one. So if the calculated E is less than 0.07 for plain and rolling terrain, or if E is 0.1, that is 10% for snow bounded areas, or if E is less than 10% for hilly areas not bounded by snow. So these are the values that you should remember. So the calculated E, if the E is less than these values, then whatever you have found the E, so you adopt that rate of superelevation. So next point what we'll do is, if at all this calculated E is greater than these values, then adopt E as 0.07 for this condition or 0.1 and find coefficient of lateral friction. So F is equal to, say I am adopting 0.07, so V square by GR minus 0.07. So we will get some value of F. If F is less than 0.15, so calculated F, if it is less than 0.15, then adopt E as 0.07. That's it. And if at all the found F is greater than 0.15, then what to do? So next step, if F is greater than 0.15, here we have calculated F, then this design speed should be decreased. So at curve what will happen is, put a signboard and allowable speed restricted, you restrict the speed, adopt 0.07, 0.15 and restrict the speed, then what will happen? So VA is equal to square root of 0.22 GR. This 0.22, what is this? So this is 0.07 plus 0.15, which becomes 0.22. So allowable speed is this one. Got it? Now also at the curves, what will happen? We will see extra widening. So extra widening. Why is extra widening required? Extra widening at curves. So suppose there is a curve and a vehicle is traveling. So we have front tires and we have back tires. So as the maneuvering takes place at the curve, the front wheels will travel like this and the back wheel will travel in this path. means we need extra width at the curves for the passage of this vehicle. So we need this extra width, right? This one, which is called extra widening at curves. Extra widening at horizontal curve, which is sum of mechanical widening and psychological widening. So mechanical widening, we have NL square by 2R, and psychological widening V by 9.5 square root of R. This is given in the code, psychological widening as per IRC, and this is mechanical widening where N is the number of lanes, N is number of lanes of the road, and L is length of wheelbase, length of wheelbase of vehicle. So from front to back, this one, this L, it is generally adopted as 6 meter for longest vehicle, and R, we know R is radius of horizontal curve, and V is the design speed of the road in kilometer per hour. Got it? Now, see horizontal transition curve. So suppose there is a straight road and there is a curve here, circular curve. Now you see, the straight road has no radius. That is, there is no radius, that is infinite. And there is a finite radius for a horizontal transition curve. Some R is there. So suddenly from infinite to finite it is not possible. So we need a transition from straight line to curve. That smooth transition from here to here is called transition curve. Now how to determine this length of transition curve? We have three types of curves: spiral, cubic parabola, and Levinskate. As per IRC 73, we are adopting spiral curve, and we have three conditions. So for smooth transition, for comfortable condition, so there should be comfort while riding in the vehicle. So for comfort condition, we have length of transition curve as VQ by CR. So we know design speed in meter per second, and this C is rate of change of centrifugal acceleration. So we already seen that at curves there is centrifugal force, we have centrifugal acceleration, and that C is 80 by 75 plus V in meter per second cube. V is design speed in kilometer per hour, and this C, this value is restricted between 0.5 and 0.8. This is first condition. And the next one is rate of introduction of, depending on rate of introduction of superelevation. That is, here to here there is smooth transition. We have here some we have superelevation here, and here the road is straight, and if you see, there is a smooth introduction of superelevation. Let us say 1 in n. So this n is 150 for plain and rolling terrains, and 60 for hilly areas. So keeping in mind these two, and 100 for mountainous areas, that's it. And this L is as per, if you take rate of introduction of superelevation into consideration, this L is E n into W plus WE. So E n into W plus WE, WE is extra widening, and W is the width of the road, and n we have seen here, and E is rate of superelevation, and this n, if the road is, so suppose this is the road is lifted here, if this is the inner edge of the road of curve, this is outer edge, then this is the formula. If the road is rotated like this, keeping in mind the center point of the road, then this L becomes E n by 2, because 50% here, 50% here. This one. So if the road is rotated about inner edge of the road, then this, if it is rotated about center line, then this is the formula. And now third condition, as per IRC, we have for plain and rolling terrains 2.7 V square by R. So this is for plain and rolling terrains. So for remaining roads it is V square by R. So we have calculated 1, 2 and 3. Whatever is the maximum of these three values, you have to adopt that one. So finally, length of transition curve, length of horizontal transition curve is the maximum of these three, 1, 2 and 3. So that is regarding length of transition curve.